forward to this for two reasons. One of them is the last time Grant and Ben spoke together was actually at Kiwi PyCon in 2014 in Wellington. Grant's wearing the shirt now, which is awesome. And I feel like this is actually going to be a really interesting complement to Chris's talk this morning, because they're both about the past and future of Python. It'll be interesting to see where opinions mesh and where they diverge. So without any other ado, Grant and Ben, thank you so much.
All right.
Thank you.
Okay. Hi everyone, my name is Grant and this is Ben, and thanks for coming to our talk on the when of Python. We've been thinking a lot about the future of Python over the last few months, and we're really excited to share with you some ideas we've had. So let's start off by considering one of the main promises of Python. That Python is simple. It's a major selling point of the language. We talk about how Hello World is so much simpler in Python than other languages. We emphasize simplicity at conferences and in the Zen of Python. But is Python still simple? Well, readability is a big part of simplicity, so let's focus on that for a minute. Okay, so what is readability? If code is readable, I should be able to quickly understand what code will do, even if I only have a basic knowledge of the language. However, if you think about all the new features Python's been adding over the last few years, they provide more than one obvious way. They make Python too big for your brain, and therefore they hurt readability. Consider named tuples and data classes, three almost identical approaches to the same task in the standard library. And the same can be said for the different libraries available for concurrency. We found a flowchart which tries to simplify the choice. It might well be correct, but oh dear.
But does any of this really matter? I mean, having choices is useful after all. Well, a few years ago, I started playing a X-Wing miniatures game, and the simplicity of this game was a major draw card because it meant that I could teach my friends how to play really quickly. But over time, they kept adding new ships and more stuff to the game, and it kept it really fresh for veteran players. However, you fast forward a few years of expansions, and the sheer volume of rules made the game virtually unapproachable for beginners. In the end, the game designers had to actually drastically simplify the game because it had just become far too complex. Like X-Wing, learnability has been a big part of Python's success. Python recently surpassed Java as the top learning language at universities, and that success has been largely attributed to its simplicity. Just last year, Python became the most popular language on the TOB index, and again, simplicity is arguably a major factor in that success. But how easy is it really to learn modern Python? Well, remember, in order to confidently read code, you must be familiar with all of the language features that you're likely to come across. Consider how much more needs to be at least mentioned in a Python crash course today compared to just 10 years ago. We've got type hinting, f-strings, the walrus operator, positional-only parameters, structural pattern matching, and that's just in the last 10 years. With so much more to learn, Python risks becoming unapproachable to beginners, especially those who aren't full-time software engineers, like scientists, school teachers, and data analysts. By alienating those users that have made Python so widespread, Python's language creep could ultimately threaten its popularity. So, should we just stop extending Python at all? Well, we still want Python to improve where possible, but additions inevitably lead to language creep because we have to keep the old features for backwards compatibility. But what we really do need is some way to shrink the Python language. Okay, so maybe we could just copy the JavaScript community. They have their JavaScript The Good Parts book, which presented a subset of JavaScript that is more readable and more reliable. And the JavaScript community really loved it, and they embraced that book. And some languages are even more aggressive. They do deprecate features and APIs entirely, contrasted with Python, which has only deprecated 4 modules since Python 3.0 in 2008. Okay, so maybe we should just write Python The Good Parts. But Python doesn't really have the same bad parts problem that JavaScript had. And what we're really saying is that there isn't enough room for all of Python's good parts. Just like how Desert Island Discs asks which 8 music albums would you take with you to a desert island, we need to ask ourselves, what parts of Python should we take with us if we can't take it all? Practically, we're proposing the Python community defines an everyday Python. That is, a limited subset of Python for everyday use. And if we can agree to use everyday Python as much as possible, then beginners will be able to read most Python code they come across, and all developers will benefit from having an agreed everyday Python that is easier to master. So I guess you could say that we're proposing that everyday Python become a Python constrictor. So instead of writing Python the good parts, we propose establishing the when of Python, which can be a guide to answer the question of when you should reach for the various features of Python.
Specifically, we propose organizing Python's features into 3 tiers. Those that you should almost always use, the first tools you reach for, those that you should use less often, but that are still the best approach for certain use cases, and finally, those that the community has decided should rarely, if ever, be used. The first tier is what we'd consider everyday Python, and is what you'd teach first in an introductory Python course. The second tier contains features that are mostly situational. Finally, features in the third tier are reserved for very specific niche cases or are considered obsolete. Now, we're going to look at how some of Python's features could be organized into the when of Python. Obviously, these are just our opinions, and we welcome a healthy debate on these. So here's our when of Python. We're going to work through each feature to explain our choices. There are some general principles behind our decisions, but we'll elaborate at the end. So let's start with string formatting. First, we had old-style string formatting. Then dot format was added to address some issues with how some data types were handled. And more recently, we've had f-strings, which have taken the benefit of dot format and combined them with a nicer syntax. Template strings also exist, which are safest for the niche case of user-provided templates. So we place these features onto the when of Python as follows. You should almost always use f-strings. They're concise, readable, and cover most cases. Dot format should be used less often now, but it's still useful for some cases like unpacking arguments. Template strings are useful, but only for user-protected templates. They're a good example of a feature that is a good part of the language, but still belongs in the third tier. And old-style string formatting should be considered redundant and obsolete. Now let's move on to data storage objects. Originally, named tuples were the standard way to quickly define a class for immutable objects that store a bunch of attributes. When typing was introduced, we got a cleaner syntax for defining named tuples. And finally, the more recently introduced data classes fulfill essentially the same role as named tuples, but can be used for both mutable and immutable objects, depending on the frozen argument. So in the when of Python, we think data classes should be the everyday go-to tool for data storage objects, while named tuples should only be used rarely. Now let's look at one of Python's most recent features, structural pattern matching. Here we have an example of using a match statement to check the structure of a dictionary and then unpack values from it. There's some real benefits structural pattern matching gives us. For one, with literal values and cases, we have a concise switch statement. We can also really elegantly unpack complex and deeply nested data structures. It's another case of stealing another handy feature from functional languages, just like list and dictionary comprehensions, etc. But all these benefits come at a cost. Match introduces another mini-language within Python, and that mini-language has some really subtle gotchas. For example, if you forget the parentheses after a type name, you'll end up redefining that type for all following code. Because this looks really similar to normal Python code, Bugs like that will be really hard to see unless you're really confident in the match mini-language. So overall, because match requires memorizing too much new syntax in order to use it safely, we think it shouldn't be part of everyday Python. Instead, it should be left for use cases with lots of tricky data structure unpacking, like parsing abstract syntax trees.
Awesome. Now let's look at Python's options for concurrency. So originally, Python only had the low-level threading and multiprocessing modules. But look how much code is needed just to perform a simple task like downloading a bunch of files in parallel. Really, there's just too much going on here, and that's not even to mention the dangerous cross-thread data mutation that's hiding in there somewhere. About 10 years ago, we got the concurrent futures module, which radically can simplify that file downloading code. In essence, the parallel processing is reduced to just this single line, and I can even swap out the thread pool executor for a process pool executor to use processes instead of threads if I want to leverage more CPU cores. So concurrent futures make it really easy to refactor existing code to be concurrent, and to see how, just look at the simple patterns in Grant's Kiwi PyCon talk from a few years ago. More recently, async I/O was introduced to Python, but just look at all the new async syntax you need to learn in order to rewrite that previous file downloading code. Even the download post function needs to be redefined in order to use the necessary async building blocks. So, is async actually a step backwards for readability and learnability? Well, it's interesting to look at Raymond Hettinger's comments on async I/O, given he is a Python core developer and respected Python teacher. He noted that it has an enormous learning curve, that we might end up doubling the size of Python in order to provide async-compatible versions of many existing tools. But nonetheless, he expected that async I/O would play a large part in Python's future. While it may be important for certain use cases, we believe the cost of learning async I/O is too high for most Python developers. So, we think that concurrent futures should be the preferred tool for Python, given that it has a simple interface for both single and multi-process concurrency. Note that we don't consider it everyday Python, as the need for concurrency at all is still relatively situational. With their steeper learning curves, we believe async I/O, threading, and multiprocessing libraries should only be used for niches where their particular benefits are needed. Okay, moving on, let's consider the for loops optional else block. So, looking at this code, it's not immediately obvious whether the else block will run if the break is hit or if the break is not hit. In practice, it's probably just clearer to remove the ambiguity for the reader by setting a variable before breaking. So overall, we're probably better off without for else. And Guido even said that if he could go back in time, he would have removed it from the language entirely. Right, to finish off constructing our win of Python, let's quickly run through a few more Python features. So first of all, list and dictionary comprehensions, etc. They're great. They should be used pretty much all the time. Formatting large numbers with underscores makes them really easy to read, and there's barely any syntax to remember here. Type hinting. While it's helpful for documentation and type safety, the general opinion seems to be to only use it in critical code, making it a situational tool. That said, it's possible some level of hinting might move into everyday Python at some point in the future. While anonymous Lambda functions are really common in a lot of other languages, especially functional languages like JavaScript and Lisp, they've never really been that Pythonic. But that said, they do still have their uses, so they are a situational tool. And finally, the walrus operator for assignment expressions. This should very rarely be used. Even the PEP itself says to prefer plain old equals wherever possible. So, here is a whole win of Python that we've kind of put together again. Hopefully that gives a sense of where we're heading with the idea of constructing a win of Python. But if you disagree with any of the particular points we've made here, feel free to tell us why after. But now let's take a step back and look at some of the principles we use to arrange the features in that win of Python. Firstly, where multiple approaches existed for a particular task, we aim to keep only one approach in everyday Python, one obvious way to do it. And we preferred approaches that are simple, versatile, and safe to use. Secondly, to achieve our goal of a simple everyday Python, we had to constrict Python. Doing so required prioritizing the common needs of programmers and preferring features that are easy to learn and to remember. It's interesting to consider whether the most recent Python features are always the best fit for everyday Python. In some cases, new features provide an all-around better experience for developers. But sometimes the new features aren't worth the cost of their additional complexity for them to be included in everyday Python. Some new features can actually be dangerous if you don't learn how to use them properly and completely. So it's not just a case of new features bad or new features good. There are some features that are just like medicine. They're only really useful if they're used as appropriate.
So where to from here for the win of Python? We need to start getting input from a wide range of Python users and eventually build towards a consensus for what a win of Python should look like. Then finally, we can adopt and standardize it. This sounds like a perfect job for the Python Steering Council, which took over responsibility for the design of Python from Guido. The Steering Council could standardize a win of Python as a PEP. It could then act as a living standard like PEP 8. PEPs for new features could include recommendations for how the win of Python should be updated, encouraging authors to think through how their additions should affect everyday Python. As Chris's keynote highlighted, Python has effectively used language constructs to reduce disagreements in the community and not leave conventions to chance. We see the win of Python as continuing on that legacy by being the next Python construct. But why not just leave Python's usage up to community convention? Well, Python is no longer a niche enthusiast language with a tight community. You have scripters, web developers, scientists, and so on. So we can't wait for clear conventions to slowly emerge organically. Different sub-communities may adopt different conventions, leading to widespread confusion. Having explicit guidance from Python's top sends a clear message to teachers, writers, bloggers, Stack Overflowers, etc., and explicit guidance is better than implicit convention. All of this got us wondering, what are the real Python conventions out there in the wild today? So we decided to take a look. We scraped GitHub for a whole bunch of recently updated Python repos and searched abstract syntax trees for various Python features. We actually had quite a lot of fun seeing what was out there. So we'll be releasing the code we used sometime soon in case anyone else wants to try it out as well. So what did we find? Firstly, to set a baseline, we wanted to look at how often you'd see a reasonably essential module used. So we had a look at the standard library module, datetime module, and we found that about a third of repos use it. Next, we looked at for else. Despite Guido saying he'd remove it with a time machine, about 1 in 10 active Python GitHub repos still appear to be using it. Then we wanted to see how often data classes are used. They were only added 4 years ago, but given their usefulness, we'd expect them to be fairly frequently used, especially in the recently updated repos that we're scraping. But they're not even used as often as for else. What?
Skip forward.
We always put one hitch in the notes. There we go. As often as data classes are used, they were added. Yep, there we go. Yep. Type hinting has only been with us for 3 more years than data classes, and yet it has been much more widely adopted. Finally, we wanted to see how often you might come across async.io and all the new syntax it brings with us. And we were pretty surprised to find it was used in about 10% or over 10% of repos. That means if you're just learning Python and your friend shows you a Python GitHub repo they're working on, there's a 1 in 10 chance you're going to come across async.io. And that's excluding the copy-pasted stats code that everyone puts on their GitHub profile, which just happens to use async.io. To put that in perspective, We also looked at concurrent futures, which is the simplest concurrency option for a large number of cases, maybe even most. It wasn't used even half as often as async I/O. This got us wondering even more, what are so many projects using async I/O for? Bearing in mind that existing learning material suggests that its complexity is rarely needed. To get a feel for async I/O's usage, we drilled into 100 fairly popular repos with over 100 stars, and about 2/3 seem to have good reasons for using async I/O, be it setting up socket servers or providing async APIs to services. However, almost a fifth seem to be not primarily focused on async, but are providing async I/O compatible interfaces. And almost another fifth seem to be using async I/O in a simple context where concurrent futures might have achieved the same goal with simpler code, such as running requests or processes in parallel. So overall, there's a lot of async I/O usage out there, and it seems like much of it could be a lot simpler. And this is just looking at the popular repos with at least 100 stars. There might be a lot more async I/O usage in the rest that could be replaced with concurrent futures. A win of Python could help fix these stats. We also feel like we've barely scratched the surface with this analysis. Language design no longer needs to make judgments in isolation, but can now reflect on how users make use of Python. You could identify diverging conventions between communities and respond proactively. And you could see what impact community guidance, like a win of Python, is actually having on Python users. There currently doesn't seem to be any consistent monitoring of Python usage in the wild, and we think that could be another real opportunity for the Steering Council. And in fact, we believe the win of Python could actually make the Steering Council's task of language design easier and less fraught. Instead of deciding between yes or no for a new feature, instead we could be deciding between when or no. Decisions no longer have to be a blanket yes, and not everything that is added belongs in everyday Python. In summary, the choice is when or no.
We also believe that asking when Python features should be used is important in other contexts as well. For example, in your project or team style guide, in teaching material, or in blog posts. Brandon Rhodes, a respected voice in the Python community, he recently highlighted how much has been written on how to use mocks for testing and how little has been written on when they should be used. In general, blog posts should put more emphasis on when to or when not to use features alongside the discussion of how to use those features. And why stop at language features? We can help define best practices for ourselves and for others by deciding when to use different libraries, when to use different approaches for testing, and when to write different kinds of documentation. So, to summarize what we've looked at today, Python isn't really as simple as it used to be, and language creep could cost Python its popularity. So we need to constrict everyday Python without giving up useful features. By adopting a win of Python, we can simplify Python for both beginners and experienced developers. And also, being able to ask when or no could even make future language design decisions easier and less fraught. So, thanks very much for listening to our talk. We'd love to hear your questions and opinions on what we've proposed here today. Is there anything you'd do differently in arranging a win of Python? Anything you'd like to add to this? Thanks very much.
Thank you so much, Grant and Ben. Now, we do have a few minutes for questions, but this is one of the most dangerous talks for questions that I've ever heard in my life. And so right here and now, I'm vetoing any questions about what categories they put things in and whether you'd put them higher or lower. That's a lunchtime conversation. Have that conversation all afternoon. If you have any questions about anything else, raise your hand. Chris.
Sure. So yeah, not going to ask questions about the categories because my talk made it pretty obvious, I think, where I disagree. How do you think Python's sort of adoption amongst multiple different communities with different use cases would affect your choice of what features go into an everyday Python, and would an everyday Python be different depending on what audience you were targeting your everyday Python at?
Well, I expect it would do. I mean, the data science community, you'd expect to have a sort of different concerns, but what you'd really want to make sure is there's a sort of a core of Python that people in your team, some might be working on web development, some on data science, that you can actually harness that Python skill within your organization to do either to some extent. So as much as possible, you try and align it, but be aware that it's almost like dialects. Well, that's my thinking.
Yeah, no, I'd agree with that, and I think it's also, you already get that kind of different conventions around certain libraries, like the way NumPy and Pandas get used can be quite different to what web developers are using, and also different communities might end up with slightly different opinions on things in here. Obviously, if you're in certain areas of web development, async.io might kind of end up further up that list, but we're kind of thinking about just general across the board, what is Python used for most of the time.
While I'm waiting to see any other hands put up, I have a question for the audience. How long did it take you to realize that the whole thing was a pun on the Zen of Python? Because I was 7 minutes 30 into it before I finally realized what they did.
3 weeks ago. Have you published this anywhere? Can I use it?
Have you published it?
We've not published this yet. We are keen to have discussions about publishing this like in the immediate future after this talk. And also obviously that code as well that we talked about with this, doing the scraping and the analysis. But really this is the kind of the launch of this idea.
Which we were even running late last night.
on flaky hotel Wi-Fi.
Yeah, using data classes and concurrent futures.
Cool, okay, I think we'll stop there. Thank you so much, Ben and Grant. And yes, I mean, immediately as soon as I put this microphone down, I'm going to tell them where they got this wrong.
Brilliant.
But people, I'm sure they will love being talked at with these opinions for the rest of the conference. So please join me in thanking Grant and Ben.
Thank you.